Tycho Brahe. He was born in the year 1546, and he was a person who was a lot observing and looking at the sky before the telescope was invented. And in the year 1560, so when he was 14 years old, he saw a total eclipse of the sun, and that in particular made him very interested in the sky. In 1572, he saw a star flare and dim away. It is now known to have been a supernova explosion of a star, and that it was a star doing that so very far out of the world was a very big indicator, or even proof, that the sky is changing. There was an ancient belief from dating back to Aristotle that the sky with the stars is not changing, it's all staying like that. But that there is a star far out, exploding and changing, showed that also the stars in the sky is changing. 5 years later, there was a comet, and that went basically through the planets. Now, and there was some belief that the planets are going around the sun on transparent but more or less fixed, all those tracks, something like tracks. And if the planets would do that, then the comet would have shattered them. So there are no tracks. The comet could just pass in between them. And from 1576 and 1596, for 20 years, 1576, 1596, he worked on the island of Ven, where he built a castle and an observatory with financial help of a Danish king, he was from Denmark, to analyze a lot of stars. 1,000 did he analyze, or calculated them down, and wrote all down what he saw. And then the last 3 years of his life, he started to analyze all the data he had collected, together with Johannes Kepler. And Johannes Kepler, then after he had died, Tycho Brahe, he calculated them on and proved through his calculations that the planets are all orbiting around the sun. And that is according to the Reader's Digest Library of Modern Knowledge, Book 1, Part 1, Structure of the Universe, written by Ian Ridper and John Shakespeare. And on page 51, there was also written that he also attended a duel and lost a part of his nose. Hi and welcome. I'm trying to learn space science today, Tycho Brahe, and after we've done that, we're going to do body center training. And if you participate in the body center training, then is that your own risk. Before we go to Tycho Brahe, or it is part of Tycho Brahe, we want to read here about Galileo and the worldview. But it's about Tycho Brahe was making a lot of things about how the world was, how the planetary system was. Two of Galileo's most important discoveries were that tiny moons orbit Jupiter and that Venus passes through phases from full to crescent. The first discovery, by revealing a solar system in miniature, showed that the theory of a larger system in which the planets orbit the sun was entirely reasonable. Galileo said there's Jupiter, and around Jupiter are moons circling. So the idea that there is a large object around which other objects are circling works. The second discovery confirmed that Venus was such a planet, for it showed exactly the expected changes in its proportions of reflected sunlight as it altered its position in relation to the Sun and Earth. I'm not really able to explain it. I don't completely understand. And it's something about Venus changes the position with the Earth, and now the shadows on Earth fit from how Earth is seeing them. I don't really get what I mean. Galileo also discovered that even through the most powerful telescope, the stars remained points of light. This suggested that they were much further away from Earth than the planets. He could see with this telescope to other planets, and they got much bigger through his telescope. But when he looked at the stars, they basically didn't change at all. That meant they are very, very much further away. So much away that even enlarging them by whatever telescope does, 10 to the 100 of thousands, or whatever it works, has basically no influence. So it must be very much away. Galileo's support for the Copernican belief that the universe was not Earth-centered brought him into conflict with the Church. But while the Church forced Galileo to disown his findings, it could not stop the widespread acceptance of the sun-centered theory. The new view of the heavens was completed in 1965-66 when the English mathematician Isaac Newton discovered that what kept planets orbiting the Sun and prevented people from being thrown off the moving Earth was force of gravity. The Earth had finally been dethroned as the center of the universe. So Isaac Newton's calculations or theories around gravity explained now why planets could circle around the Sun. And why human beings can just walk completely around the Earth in a year and downfall the other side down. The Earth's movement explained. Even so, direct observational proof that the Earth moves in space was still lacking. This did not come until 1728, when the British astronomer James Bradley used a powerful telescope to discover evidence of the Earth's movement in the form of an effect known as the aberration of starlight. Further proof was provided a century later by the German astronomer Friedrich Bessel, who in 1838 detected the parallax, or apparent change of position of a nearby star due to motion of the Earth around the Sun. From this, he was able to work out the distances of the star from the Earth. A final demonstration of the Earth's movement, showing how it spins on its axis, was provided in 1851 by the deviation in the plane of swing of a giant pendulum set up by the French physicist Jean Foucault. Meanwhile, telescopes were also extending the knowledge of the known solar system. In 1781, William Herschel, a German-English astronomer, discovered a new planet Uranus, thus providing that the solar system stretched beyond Saturn, the outermost planet visible to the naked eye. Telescopes eventually revealed the existence of two more planets, Neptune in 1846 and Pluto in 1930. Herschel also began to survey the distribution in space of the stars in our galaxy, which he considered to be the extent of the universe. He saw that the Milky Way region is thickly populated, whereas away from it the stars are thinly spread. He saw that the Milky Way region is thickly populated, whereas away from it the stars are thinly spread. He deduced from this that the galaxy extended around the Sun in the shape of a disk. Galaxies beyond our own. There were still radical changes to come. In 1918, astronomy dethroned the Sun from its privileged position in space. In that year, the American astronomer Harlow Shapley demonstrated that the Sun lies about 2/3 of the way towards the edge of the galaxy and is simply one among countless other stars, many of which are known now to be much larger than the Sun. For 2 centuries, even the belief that our galaxy formed the total extent of the universe had been questioned. In 1924, this belief was finally shattered when another American, Edwin Hubble, proved the existence of other galaxies beyond our own. Many of these are far larger than our own galaxy. Tycho Brahe. Born 1546, Danish astronomer who was the greatest observer of the heavens before the invention of the telescope. He first became interested in astronomy when he saw a total eclipse of the Sun in 1560. When his own observations showed errors in existing tables of planetary motion, he resolved to make more accurate observations. Brahe made his name in 1572 by showing that an object which flared up in the sky that year was a star. It is now known to have been a supernova or exploding star. This disproved the belief dating back to Aristotle that the heavens were eternal and unchanging. 5 years later, Brahe hammered home the point by proving that a comet of 1577 moved among the planets and not in the Earth's atmosphere. From 1576 to 1596, Brahe worked on the island of Hven at a large observatory provided for him by the King of Denmark, using only the naked eye. Brahe produced a catalogue of 1,000 star positions and made invaluable observations of the planets. During the last 3 years of his life, he began to analyze these results with the young German mathematician Johannes Kepler, and it was on them after Brahe's death that Kepler was to base his laws of planetary motion. Brahe was a colorful personality as well as a great astronomer. As a young man, he lost part of his nose in a duel and fashioned himself a new one from gold, silver, and wax. I'm going to start the second camera and try to say the last part about Tycho Brahe. '46, born 60, then 72 the supernova, 77 the comet, and 76, 96, 20 years observatory on the island of Venn. 1000 stars, analyzing with Johannes Kepler, helping Johannes Kepler. Kepler discovered another vital principle. So he found out that they are elliptical, not circular. That was Johannes Kepler. One that would eventually enable astronomers to calculate the size of the solar system. Kepler believed in a sun-centered universe. Copernicus also, and Galileo delivered more confirmation. Both the German mathematician Johannes Kepler and the Italian physicist Galileo independently confirmed that the planets orbit the Sun. Kepler, through his calculations, and Galileo by telescopic observations of the phases of Venus as it moved around the Sun. Kepler's calculations showed that the planets orbit around the Sun are not circular, instead they move in ellipses, of which the Sun is at one focus. Galileo's telescope enabled him to draw details of the Moon's surface, such as its craters and mountains, revealed at its various phases. Tycho Brahe. He was born 1546, and he was a lot observing the universe before the telescopes were invented. In 1560, he saw a total eclipse, and that made him also especially interested in the sky. Then, in the year 1570, he observed a supernova. It was 1572. It was a total eclipse of the sun. Tycho Brahe. He was born in the year 1546, and he was a person who was a lot observing and looking at the sky before the telescope was invented. And in the year 1560, so when he was 14 years old, he saw a total eclipse of the sun, and that in particular made him very interested in the sky. In 1572, he saw a star flare and dim away. It is now known to have been a supernova explosion of a star, and that it was a star doing that, so very far out of the world, was a very big indicator, or even proof, that the sky is changing. There was an ancient belief from dating back to Aristotle that the sky with the stars is not changing, it's all staying like that. But that there is a star far out, exploding and changing, showed that also the stars and the sky is changing. 5 years later, there was a comet, and that went basically through the planets. Now, and there was some belief that the planets are going around the sun on transparent, but more or less fixed, all those tracks, something like tracks. And if the planets would do that, then the comet would have shattered them. So there are no tracks. The comet could just pass in between them. And from 1576 until 1596, for 20 years, 1576, 1596, he worked on the island of Venn, where he built a castle and an observatory with financial help of a Danish king. He was from Denmark, to analyze a lot of stars. 1000 did he analyze, or calculated them down, and wrote all down what he saw. And then the last 3 years of his life, he started to analyze all the data he had collected, together with Johannes Kepler. And Johannes Kepler, then after he had died, Tycho Brahe, he calculated them on and proved through his calculations that the planets are all orbiting around the Sun. And that is according to the Reader's Digest Library of Modern Knowledge, Book 1, Part 1, Structure of the Universe, written by Ein Rittberg and John Shakespeare. And on page 51, there was also written that he also attended a duel where he lost a part of his nose. Oh, that's not okay. And that was the space science part. If you were here for space science, you can go directly to the next part of space science. We'll continue with space science. If you stay here, participate in the body center training. Wenn es wirklich cool ist. The feet are standing shoulder width wide apart. Down into the knees, legs, press them together, straight one leg. Bend it. Upper leg, straighten it. Bend it again and up. With the palm for legs, into the knees, legs for legs, press them together. Go on the other side. Relax. Middle and up. Closer together, rest to the outside. One leg up, into the right angle, legs forward, even aligned hips. Taller with the back, and press from the top against the knee, a little bend in the elbow. You don't have trouble so much time. And press up and to the side. And press on the outside. Close. Upper leg. Outside. And up to the side. Press on the outside. Close. And for the exercises on the ground, first the side plank. Bend with one leg up. Now on the long arm, one arm out, one leg up, with the knee to the elbow. And over, and the same on the other side. On the elbow. With one leg up. And on the long arm, one arm out, leg up, pull the knee to the elbow. And up again. One heel onto the ground, pull the toes in, move the leg from left to right. Other heel onto the ground, pull the toes in, move the leg from left to right. One knee up, the other one. Take the leg at the ankle, tuck the tail on it, change. Legs to sides, breathing along. And breathe out. In and up. And out. Breathe in and cross the legs. And breathe again out. That was the body center training. I thank you very much. And until next time.